Hi and welcome. This is a really quick project. I have 3 of these pipes that I have to cut into 6-inch sections, and I need to chamfer the ends to 37.5 degrees off of horizontal here, or perpendicular to the axis of the pipe. And so in order to do that, I'm going to use a form tool to do this. I think it should work fine because it's a fairly small wall thickness relative to a form tool, so I think it'll be okay. However, I want to hold this in a 5C collet, and guess what? The diameter of this is really odd. So I don't have a proper 5C collet for this, so we're going to bore out an emergency collet that's already been used once before and make the proper size. I have an emergency collet loaded up here that's already been bored once before, much bigger hole than it comes with. Here's a brand new emergency collet. You can see how small that center hole is. So this is significantly larger, and we need something about 0.832, so that's where we're headed. So I drilled out the center to 1/2 inch. And I'm just going to see if I can open that up enough to get this boring bar in. Going to get a finer finish going in slower feed rate. That 5C collet is to hold this stainless steel tubing that I showed you earlier. So I've got to cut a bunch of the stainless steel tubing into approximate 6-inch lengths. I'm actually going for 5 3/4. And for a stop, I'm just using these magnetic switch blocks here. And what I really mean to do is make a fence with these guys that I can just put anywhere on this table here. But in the meantime, this is what I'm doing. So we're just cutting. We got the saw slowed way down because this is stainless steel. So we're going about 90 surface feet a minute. And we're just cutting right through them. I have 2 more of these 6-foot lengths coming tomorrow. First step in this process is getting to make sure my cross slide, which is on 0 here, is actually 0 relative to the ways. And unfortunately I need a longer arm. There's like 1/2 thou over 3 inches, less than 1/2 thou over 3 inches. So I think we're pretty good there. So once I've got this square, then I need to get my tool post square to this, because what I'm going to do is I'm going to end up rotating this guy to 37.5 degrees. So first I need this at 0 so I can make this guy 0 relative to it, because I've got a tool holder here that is just a perpendicular tool holder. So I'm going to cant this at 37.5 degrees and use it like a form tool. So that's the plan for that. But in order to do that, I have to get this square to the ways. In order to get this square to the ways, I need this square to the ways. At least that seems the logical approach. To square up the tool post, I use the Quinn-Dunky method. We'll call it the Dunky method, which is use a 1, 2, 3 block between the tool post and my chuck face. Square that guy up. And tighten it up. That should be good. All right, so I set the height of the tool. This is free to move now, but currently at 0 degrees, it is parallel to this perpendicular face here, or perpendicular to the axis of this tubing, which is what we want. And the chamfer we want is 37.5 degrees in this direction. I've got it roughed in. I've got the angle roughed in right now. Now let's see. Can we get there from here? Will I be able to get over to the part? Yes, we will. Good, 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 good. Okay, got lots of spare area to run the tool through here. So we'll be able to chamfer this guy. We're going to be using a 5C collet chuck here instead of this, but I left the chuck on here just for the setup. Now I've got this set to 37.5 degrees via the vernier scale on here, which is probably plenty accurate. But if I wanted more accuracy, I could grab my Tangent Engineering sine bar and set the angle. So I have my Tangent Engineering 4-inch sine bar here. It's magnetic. Fits on the compound just like so. You load your stack of gauge blocks right here. Now he has a custom set of gauge blocks here for all of the, I think, Morse taper settings. Yeah, Morse taper block set blocks. So the set itself comes with a bunch of tables that tell you for all of his different size sign bars what set of gauge block stack you need. Here's the set for Morse tapers for the 4-inch sign bar. All of those are included in this set, which is an insanely decent price. 0.10406 right there is the first one for Morse taper 0. So you don't even need to build a stack of gauge blocks if you buy this set. He was charging 40 bucks for it. I think that's too low. I think you should ask for more, but pretty amazing. So you set that under here and you set the angle and you're good to go. Now, one pin is on the side of the compound. The other pin is touching the stack of gauge blocks. The stack of gauge blocks for a 4-inch sign bar for 37.5 degrees is 2.435 inches. Now I just got to run an indicator along here and find my 0. That's a little bit challenging because I don't have a good spot in here. I need to make a bridge that'll sit over here to help me do this, because I've had problems with this before, having the cross slide run into this guy. I'll make a 0 over here. Maybe that'll be easier for you to read. Okay. So there you go. So it's increasing. One more time. Wow, okay, nailed it. No movement across the range. And that's it. We're set at 37.5 degrees to within some pretty tiny amount. There you go. Thank you, Tangent Engineering. Very handy tool. If you need to go check out his YouTube channel, is Tangent Jim. Gives you all the instructions on how to get a hold of him if you want to buy one of these. Pretty fantastic tool. By the way, I'm loving my T-slot covers. It makes cleaning up the cross slide here a breeze when I'm done at the end, because I clean up at the end of every day. And there's a little bit of debris getting stuck in there, but not much at all. Really fantastic addition. All right, so we've loaded up our part with the collet puller, which means I'm gonna have to retract this guy out of the way. And I can release the part, put it in. What I need is a stop in the back of that part. I'm gonna have to solve that problem too. I need to clean up the inside of burrs on the part. And then I just want about a 50,000th land. And that's about it. On to the next one. That's it. One thing I notice is that since I didn't part these off, the edge of this material has the scratches from the saw cut, and I don't know if that's acceptable. I might have to run a facing cut across here to clean that up and then do this chamfer. Well, we'll see. So I cut out all my pieces. I just deburred the inside lightly and the outside gently in a 3M EXL wheel. I want to bring you in so you can see how much run out there is in this tubing. If they wanted accurate, they'd need DOM tubing. This tubing is seam rolled right there and welded, so it's not perfectly round by any stretch, and you can tell the run out, especially when you look at the end here for the landing I've created. It's not perfectly equal all the way around. Some high spots, some thick spots, some thin spots. So the tool I was using was my shear tool, and I made it so that it could be dual purpose, which is pretty cool. So it still works in the normal configuration that the tool is intended to work under, which is flat, because I left two sides parallel so it could still sit flat like this. But then the angled section, see it's a rhombus, the angled section still allows it to be set up as a shear tool the way it was designed to be used for. And we're good to go, back the way it normally is meant to be. So it's either a shear tool or a horizontal tool. And normally you think horizontal tools wouldn't be terribly useful, but I just showed you an example where, you know, using it like a form tool, it actually worked out pretty well. Oh, except I made one little mistake here. Beautiful. This tool normally operates in the tool post on the other side, coming out this way. And then it goes this way. Obviously with the tool post horizontal, which I can flip back as a matter of fact. Tool post normally sits like that. Here we are done. There's the chamfered ends with a land. I asked them if the saw cut roughness was fine, and the customer said yeah, they're going to weld through anyways. They don't care if they meet perfectly. They're actually going to leave them separated by a little bit, so they're actually fine with that. Weld coupon's done. I know this is a quick one. Thanks for watching. Hope you find it useful. Hope to see you next time.